Hi everybody, I'm giving you a little run through my testing rig for testing and showing some vintage lamps which are in the collection. These will be appearing from time to time. This setup is the easiest way of doing it. Firstly, we have a variable voltage transformer, a Variac, which I've graduated in certain volts. At the moment it is set on 25 volts. As we go round, I can set it for 50, 100, 150, or to our voltage 200, 220 or 240 as it is marked. This enables me to gently bring up to voltage unusual lamps like squirrel cage carbon filaments, where suddenly putting them onto the full voltage could really damage the actual filaments, and that's the important point. We have here an example of a lamp which I can test. I use a screw socket, Edison screw, which I can screw in an adapter which converts it to a BC, a bayonet. The lamp I've just put in for demonstrating purpose is a black glass lamp. It's one which has a self ballast filament inside. For the purpose of this I will show it a light. As a safeguard, I can only draw up to about 1 amp from the Variac. This enables me to be able to let you see what happens without really pushing it. I'm about to turn it on. Let's see what happens. This is a black light lamp which is used in theatrical productions. It is not too good to look at the lamp for too long. It's not as dangerous as the germicidal lamps, but nevertheless it's not to be recommended looking at it too long. Right, you see it's showing the ballast filament within the lamp itself. You can see the arc tube, and what happens, or what it should happen, when I whack it up to full voltage. Have to remember that this is on a 1 amp Variac and the lamp actually takes more than 1 amp, but I think you'll be able to see how it functions. Rather than push the full voltage through, it's better to see how it works rather than just see a pretty light. It will in fact, working at full voltage or full current, give out a UV light, but I've left it on at that at the moment to give you a demonstration. I'm going to turn it off. And let's have a look at the actual lamp. At the moment it's very, very hot. So just on for that short length of time it does get hot. I don't know whether I can actually show the information on it. I think I may be able to. It's upside down at the moment. Let's turn it round. Get it right, we'll see what we're doing. I think you can just make it out. It's a GEC MBTW/V, and it's at 175 watts, 220 to 250 volts. There we are. And as you can see, it's completely black glass. These do run at quite a high temperature, so if you're using them, be very careful. There is another version of this which looks identical which uses a separate ballast. The only difference that you'll see outwardly is the one that uses the ballast has a BC base with 3 prongs as opposed to the standard 2. Here we have the lamp that I was just displaying. As you can see, it's a standard BC or B22 base with the normal 2 pins. This one is safe to be plugged into a 240 volt source, no problem. The other one outwardly looks identical, but looking at the base, it has 3 pegs or pins. There's no way that you would be able to plug that into a normal holder, but it is one which has to be used with a ballast in series. This restricts the current flow through the arc tube. With the other one, the current was restricted by a tungsten filament as a mixed light lamp. These are quite popular and readily obtainable, but these black lamps are quite old, not ancient but fairly old. As far as I know, this one is a worker. I haven't tested it with a ballast, but there we are, the 2 types. I hope this has been educational, and any questions please ask. I will be listing posting other items which may be of interest, ranging from carbon filaments through to squirrel cage, neons, and anything that I think may be of interest. Anyhow, thank you for looking.